Okay, this is our second podcast of our acid-base unit, and when we're getting around to actually calculating pHs. And because of that, we're going to need a calculator, and you need to make sure that the calculator has a log button and can do exponents, because we're going to be doing a whole lot of 10 raised to a certain power. And a negative button is actually also going to be needed. So make sure you got one of those. I'm going to post a link to a calculator emulator so that you can get to one that looks just like the one that I'm using right now that came from our classroom. So we are going to be filling in pages 6 and 7, and it is rather dense calculations, but the process goes pretty quick, and we just need to kind of practice this process. So, acid-base calculations. Where this all came from was from this equation that you see here of water breaking apart into these ions, this H plus and OH minus. And this does happen spontaneously. You'll notice that it is a double-sided arrow, so it doesn't completely break apart into ions, but just randomly sometimes it does form ions. And we measured the amount of these H pluses and OH minuses that exist in water, and we found that we could always take these concentrations, and honestly, the numbers in all of this and the calculation part of this right now is not super important, but I do want to point out we're going to be using this a lot. This square brackety things are shorthand for concentration in molarity. So this isn't just another type of parentheses to us. This in chemistry speak means molarity. So it's a great way of cutting down on how much you have to write, but please make sure they are square brackets if you're going to use them. But long story short, lots of very smart people calculated these concentrations and came up with this equation that set the ratio of these H pluses and OH minuses equal to the constant. That constant is 1 times 10 to the negative 14th. And just as a reminder, in our calculators, when we use that number, instead of the times 10 part, we're going to use E. So we're going to put 1E negative 14 in there. And having those numbers equal to a set constant meant that we could use this equation to predict the ratio or the amounts of H pluses and OH minuses in other solutions where they didn't have predictable concentrations. So we're got a couple of problems doing that right here, right now. This asks us to determine the hydrogen ion and hydroxide ion concentrations in this solution. Now, it says HCl. What I want you to notice, that HCl is an acid. When that breaks up, it's going to break up into H plus and Cl minus. And so that HCl is equal to our H plus concentration. Because this is a strong acid, it is going to completely break up. All of those HCl's are turning into H pluses. We are not going to ask you to do any of these calculations with weak acids. That is AP chemistry and college chemistry right there. So, if I give you an acid or a base concentration, like in the next one, assume that that concentration is equal to your H and OH concentration, respectively. So, I already have one of my answers. Yay! My H plus concentration is 1 times 10 to the negative 4th, because that's the number that was given to me. But now, I can use this equation. 1 times 10 to the negative 14, which is that ionization constant for water, is equal to this H plus concentration I just found, times the OH minus concentration that I'm looking for. So if I divide by that H plus concentration to get OH on its own, I end up with this equation, which, if I plug that into my calculator, gives me 1 times 10 to the negative 10th, or 1e negative 10 molarity. So that tells me about how much H's and OH's I have in this other solution that's not water. And next question is basically the same process except with OH. So that is my OH concentration, and I'm still going to be dividing that KW number by the concentration I know to find the one that I'm looking for here. So we can find those numbers pretty quick and easily, but honestly, those numbers are probably not super useful to you. They're kind of crazy concentration numbers. No one really likes scientific notation, and you're used to looking at a pH scale with some nice simple numbers on it. So all that people had to do to take those crazy concentration numbers that they were measuring and turn it into some numbers that people actually wanted to use was take the negative log of it. And we'll get into that math number stuff in a while. But that put acids, bases, and neutral substances on this nice scale that goes from 0 to 14. And we call that the pH scale. P stands for the potential. H is, of course, hydrogen. So it's not directly measuring the hydrogens, but it's kind of related to the number of hydrogens, so that's why we call it pH. And what you might not know is that just like we can measure how many OHs are in the solution, we also have an OH, a POH scale, rather. And that is very similar, but opposite from our pH scale. We still measure the same things, and they're still in those same places, but the numbers are kind of backwards here. Now, that pH and POH just came from taking the negative log of those concentration numbers that we were measuring before. And when you take the negative log of those, if you take do the same thing to that equation that they had come up with before, then that turns it into this equation, that the pH plus the POH are always going to equal 14. So these are our main tenets of our acid-base calculations. Honestly, these two calculations here are almost exactly the same. The only difference is whether it's H or OH in here. So on your equation sheet, you are given this pH equation and this equation, and that's really the two that we use the most. These other ones over here are kind of working backwards. The opposite of a negative log is raising something to the 10 to the power of that something. So if I were to try and find this concentration, to get concentration by itself and solve for concentration, I'd have to take 10 and raise it to the negative of whatever my pH is. And same with OH. If I want to find that, I do 10 to the negative POH. And at least at the beginning here, this is going to be, honestly, one of the more useful equations for us. Not because we're going to be calculating it, but because we're going to use this, what I call the exponent rule. If I'm trying to find the pH and I'm given a concentration, and that if that concentration's in a special form of 1 times 10 to the something, that exponent something is the pH or the POH. It's just making sure that it matches. If that ion is the H ion, H+, then that exponent is our pH. If that ion is OH, then the exponent is the POH. So they always match each other. So let's go ahead and use that exponent rule. I have to point out, though, all of those equations here are going to be given to you. They're all right there, but I want to put them in context real quick, actually, before we start using it, because we've talked about how to get from pH to H+. Is these two equations that we have there in the middle of your page. And I've pointed out that the POH and OH formulas are basically the same. It's just with OHs in there. Now, to link together these two sides, my favorite way of getting between the pH stuff and the POH stuff is using that idea that they add up to 14. Because I can do that math in my head. But technically, we can also do this conversion, that original equation, that KW equation equals the H plus times the OH minus. It's just trying to type in that scientific notation correctly and do the algebra to rearrange that correctly is sometimes a pain, and people make mistakes. So honestly, this is a big circle. There's lots of times where I'm going to be trying to get from here to here, or even from here to here, and I will go the long way around to get there because it's actually faster for me to go all the way around this way. I don't like using this, but some people do. So we'll get back to that in just a bit, because these first few calculations honestly are going to use that exponent rule, not really the calculator so much. So here, question number 1, these calculations are trying to get us to find the pH if I have my concentration. And this concentration, if you notice, are all 1 times 10 to the something. Well, that something is our pH. Here my exponent was 9. So my pH is 9. This next one, my exponent is -6. That pH is going to be 6. There's always going to be a negative up there, but the number part of that is going to be your pH. Now, this next one isn't so nice, but as we'll learn later, you can always just take the negative log of a number if it isn't in the right form. But this one is almost in the right form. Technically, I could put that number into scientific notation, and then it'd be in the right form, and that exponent is a 2, so my pH is 2. I could also, like I said, go and take the negative log of 0.0100, put that in my calculator, and that would give me 2 as well. So there's multiple ways, multiple directions that you can solve these problems. Now, what type of solution is just asking acid or base, practicing that idea. Remember, acids are less than 7 and bases are bigger than 7. So this is going to be a base first and then 2 acids. Next, we're going to do the same thing with OH. Here I have my OH concentration, looking for the POH. So we're just going to use that exponent up there to find my POH. Once again, that last one is a little bit easier if I have it in scientific notation. Or I can just do negative log and get 3. Then it asks me to find the pH. And I do use the pH to classify an acid or base. There's no use remembering the pH scale and the POH scale. So convert it to pH when you're in any doubt. And the great thing is, all we have to do is ask ourselves, what would I add to this POH to get to 14? So 5 plus 9 is 14, then 10, and then 11. So those are my pHs, and all of those are bigger than 7. So that is a base. Now, 3, we're going to go the opposite direction. Take the pHs I've got and make them into our H plus concentrations. But we're still going to look at that same basic structure here. It's telling us the H plus concentration is 10 raised to the negative pH. Now, while this 10 to the negative 4 is technically correct, if you remember, all of our concentrations are given in proper scientific notation, not just that random math-looking problem. So we should write this answer as 1.00 times 10 to the negative 4th. Just focusing on getting that times 10 to the negative 4th. And of course, multiplying by 1 doesn't change anything. It just puts it in the right form for a number. So this next one is 1 times 10 to the negative 5. Then 1 times 10 to the negative 7. And now, technically, this is 1 times 10 to the negative 0, or 0, which is always 1. So, just putting those numbers back together here. Going to take a step to go from pH to POH first by finding what I need to add up to 14. So that's going to be 0, 12, 10, 13. Just because those two columns always need to add up to 14. Then finding this concentration, just like I did with the H+. Just take that 1 times 10 to that POH. 1 times 10 to the negative 12th. 1 times 10 to the negative 10. So just following that process, that structure. Oop, that didn't belong there. Now, it does, of course, get a little more complicated than this, because if that pH and POH aren't nice whole numbers like 2.00, or that scientific notation doesn't have 1.0 as the base, even if, like you see down here, it's 1.45, it's so close, but not quite. It's not going to be able to use that exponent rule. We're going to have to use the calculator. Now, it's not that complicated, but you're probably not going to be able to do as much in your head. So, what we need to remember is this map, and especially now when our numbers aren't going to be nice round numbers, we might end up going opposite directions. If we're trying to get from here to here, if we go opposite directions, we might get slightly different answers. So don't be too worried if your answer is close but not quite. Ask me, touch base with me just like you usually do, but there's a chance you might have just gone another direction, so I tried to kind of show my work in these. So, in this question 5 calculations, we're going from H plus to pH. Now, If we're finding pH, this is going to be our negative log situation, where all we got to do, before we just looked at that exponent, we can't do that if this isn't base 1. So it's going to be close to 9, but not quite 9. I have to take the negative log of this number, so I'm going to be typing in 1.45 e negative 9, closing that parentheses, pushing enter, and that's going to give me 8.84. Take a negative log of that next number, gives me 5.70. This next number, it doesn't even matter that it's not in scientific notation anymore, because it's not a nice round 1 something. I'm just going to plug it in as is. Negative log of 0.0180 is 1.74. So these are our pHs, and even as decimals, this 8.84 is bigger than 7, so that's our base, and these next two are less than 7, so those are acids. So slightly different implementation, and you need a calculator to be able to do this. You can't do logs in your head. At least I can't. So use your calculator. If you need help figuring out how to work your own calculator, log on to a live classroom and I'll walk you through it. Okay, same process again. I have my OH concentration and I'm looking for my POH. So I'm just going to take the negative log. Honestly, when in doubt, use your negative log. That's going to get you places. So I'm taking negative log of each of these numbers that I was given to get the POH. And then to find the pH, we need to remember that they add up to 14. So even as decimals, we're just going to be subtracting. 14 minus my POH gives you my pH. And once we have pH, we can decide what type of solution it is. All of these are bigger than 7, so those are bases. And then question number 7, trying to get from pH to H+. And here, this is where we wanted to just be able to put this up there as the exponent. And it'd be so nice if we could still just do that. And it's almost that easy. It's just that math doesn't allow us to leave little decimals in our exponents. So we are going to do it 10 to the negative 4.15. We're just going to do it in the calculator and have the calculator put that into the right form. So you might have to use a little up caret to get that into the exponent, or if you have a calculator that has a 10 to the x button, then you push 10 to the x and all you should have to put in there is 4.15, or it might have you put in that negative 4.15 first, and then you push the 10 to the x button. Everyone's calculators are their own unique animal, which is why I tried to make sure you always had the same ones in my classroom, but we'll manage one way or the other. We should be getting 7.08 times 10 to the negative 5. It's really easy to forget that scientific notation stuff at the end. So always check down there at the end. Doing the same thing here. 10 to the negative 5.35. 10 to the negative 7.23. And then anything raised to the 0 power is 1. So those are our answers. So it's not quite as easy as it was before, but it's the same basic idea. We just have the calculator fix it up a little for us. Now, last set of calculations, going from pH all the way around to OH. And I feel like the quickest way to get there is to go to the POH first, because those will always add up to 14. And then once I have these POH numbers, I can just do 10 to the negative POH. So 10 to the negative 0.68 gives me this, and then 10 to the negative 3.55, 10 to the negative 11.35, and 10 to the negative 9.44. Gets me all of those answers. It's really about the calculator work. So if you're following along and just writing down these numbers, yippee, you've got all the numbers written down. It's probably not making much sense. Just commit to pushing the buttons. The calculator does all the work. It's negative, log, type in the number, or 10 raised to the number. It's not much. There's not even much algebra with it. So do it. You can do it. Now, this last problem is actually the same as the first problem that we came across on page 6. And I just kind of wanted to reinforce the fact that there are multiple ways of working these out. When we were given that H plus concentration, that HCl, we went about it another way, but after we work this out, I would honestly look at that and say, oh, that must mean the exponent is 4, my pH is 4. Then I can real quickly jump to the fact that my pOH would be 10, because they add up to 14. And then that means that my OH concentration is 1 times 10 to the negative 10. So even though I'm trying to get from here to here, I'm going the long way, yes, technically, but I can get there in a couple of seconds. The other direction that we went when we first started this, when we were using that KW equation and plugging this in, I could probably figure it out, but it's going to take me longer, and the possibility of me making a mistake or flipping up those numbers is huge. And I know it's not just me, so I would really suggest you don't worry about this side over here, unless you know who. You're that amazing, and you can do anything you put your mind to. But I like to use these 3 over here, because these 2 are almost the same, and this one makes me happy, because it's nice and simple. So, develop your process, work it, practice it on this next page, page 8. I don't need you to complete all of page 8. It's actually a lot of calculations, especially in that table up top. There's a lot of dense calculations in there, but they're not due this week. I want you to get started on them, figure out where you're struggling, but I'm going to work with you some this week and some more next week to get more comfortable with these pH calculations. Now, one thing I noticed as I was looking over these is that they didn't have any of those nice simple problems that we were working in the beginning, that 1 times 10 to the negative 5, where the answer is 5. So I put together an optional extra practice, and it is completely optional, but it starts from those basics. So on our information package, there is a link, and it tells you right there it's optional too, but it's a fun little kind of secret message puzzle where you can practice some pH calculations, check your work as you go along, and hopefully get better at some of the simpler stuff so you can feel more confident if you're getting stuck on page 8. So come to my live classroom if you need help with this or you have any questions anywhere in it, but just try and make some progress on it. Good luck.